This video is part of an international industry-wide effort to reduce controlled flight into terrain. The Flight Safety Foundation formed a task force to produce a CFIT education and training aid. This video is part of that aid and was produced by Boeing.
Flight 66 was a Boeing 747 cargo flight en route to Kuala Lumpur, Malaysia. The first officer was flying the approach to runway 33 during the pre-dawn darkness. The ILS to runway 33 was out of service, as reported in both the current NOTAM and arrival ATIS. The crew, after being cleared by ATC to fly an NDB approach, misread the descent clearance and is descending to 400 feet instead of 2,400 feet.
Looking good. Gears down, tilt checks, nav and auto flight down. Go all the way on the check, please. Speed brake. Set. You want any kind of brake? Yeah, let's put the brakes on. Put them on middle. Okay. They're given 8,000 meters of visibility at this time. What? Whoa, up. So you got... Whoa, up. So you got the ILS there, right? Yeah. I'm going to put you on 14.7. And that'll give you... Whoa, up. Whoa, up. Whoa, up. Whoa, up. Whoa, up. Oh, I've got 100 feet on the shit. Whoa.
In the first half of the 1990s, almost 2,000 people died in accidents attributed to controlled flight into terrain. As you can tell, CFIT accidents and incidents can happen anywhere, at any time. The difference with an incident is that the last link in the chain held. The crew was trained and responded to a GPWS warning. The ATC controller noticed the airplane descending towards terrain, or standard operating procedures were effective. Remember, everyone must be involved. Because of the international increase in air traffic, CFIT projections for the next 20 years show that if trends continue, worldwide, we can expect to lose one large airplane to a CFIT accident every other week. That's 28 airplanes, and the hundreds and hundreds of people on them lost every year. These statistics conceal the human sadness, as well as the commercially devastating effects on an air carrier's business.
Samantha Smith, the young Maine schoolgirl whose wish for peace put her in the world spotlight, has died with 7 others in a fiery plane crash.
On March 20th, 1975, another CFIT accident occurred right at this point. It happened at night. The weather was clear. It was the end of a very long crew duty day. The crew could actually see the landing runway. They died less than 500 feet from the top of that ridge. Why would pilots fly perfectly good airplanes into the ground? This question is at the heart of our investigation into the causes of controlled flight into terrain accidents. We're going to show you how pilots can get into a CFIT situation and ways to avoid these traps. You'll see how changes to the way the aviation industry does business can improve the way we all think and act about safety. Finally, we'll talk about effective approaches to training. To see what the industry has been doing to reduce CFIT accidents, let's look at some history.
In the late 1960s, as part of the Category 3 all-weather landing system, radio altimeters were installed on many airplanes. For the first time, pilots had a comparatively reliable indication of their height above terrain. The next major improvement was the ground proximity warning system. Agencies around the world began mandating GPWS for all large airplanes beginning in 1975. In one area of the world, before the installation of GPWS was mandated, hull losses for large airplanes were averaging 8 a year. With the requirement for GPWS, the CFIT hull loss rate is currently about 1 every 2 years. CFIT accidents can be reduced. This is significant because the decline has occurred even though the airplane fleet has almost doubled and the number of flights have tripled. Don't be misled, however, by these low accident rates. Incidents that could have resulted in accidents are still occurring daily throughout the world. According to some experts, a CFIT incident occurs at least every 2 weeks, even in those areas considered the safest. GPWS still forms the last safety net. We still have room for improvement. Remember, high-technology solutions are no substitute for good airline philosophy and flight deck management.
1,000 above. Cross-check.
The International Civil Aviation Organization, ICAO, mandated the installation of GPWS in the late 1970s. However, about 300 of the world's jet transports still do not have ground proximity warning systems. This is about 3%. This 3% generates 50% of CFIT accidents. Not surprisingly, it's also the oldest generations of aircraft that have the highest accident rates.
Charles 84, go ahead.
Charles 84, show your altitude at 12,000. Your assigned altitude is 13,000. Stay altitude.
It's not just GPWS and the upgrades to it that have reduced CFIT accidents. The installation of altitude reporting systems alerts air traffic controllers by using visual alarms when aircraft penetrate or are predicted to penetrate a minimum safe altitude in the terminal area. While the installation of these systems is limited, the continual investment by air traffic services in expanding and upgrading ATC radar, the minimum safe altitude warning system, along with runway navigational aids and procedures, will help reduce the CFIT risk.
To solve CFIT problems, we require commitment from all people throughout the aviation industry. We must advocate a safety culture because it's the right thing to do, and besides, it's just good business. In our company, we constantly talk about how to improve safety. It's an obsession with us, and it should be with you. There are no excuses not to provide our customers with the safest air travel possible.
Solid investment in training is of the greatest significance. Nothing stands still where safety is concerned. And although operational circumstances are constantly changing, safety will always be the key element in our planning. All of Japan Airlines people are dedicated to safety. That is our mission.
Full implementation of the GPWS requirements and of the controlled flight into terrain prevention program are essential in order to meet the objective of 50% reduction in the global controlled flight into terrain accident rate by the year 1998.
The commitment that the aviation industry showed in the effort against the problems of wind shear and mid-air collisions shows our efforts can make a difference. Accident fatalities used to be divided between CFIT, mid-air collisions, wind shear, and other. Of these, controlled flight into terrain accounted for less than half of the total. Here's what we can do when we work together. By the end of the 1980s, increased awareness and improvements in training, along with new technologies such as TCAS and wind shear detection, have reduced mid-air collision and wind shear accidents, and they almost disappear from the charts. But look what happened to CFIT. It grew to 81%. Why are CFIT accidents so difficult to prevent? One factor is just human nature.
I'll see it coming. I know what to do.
Did I ever not know my position? Well, I'd never admit that.
I've never flown in weather that's too bad.
Hey, I've always found the runway.
I'd never make that kind of mistake.
Listen, I've been flying that route for years, and I know my airplane. It's the most modern one in the fleet. It will never happen to me. Never.
Well, it does happen. Given the right chain of events, CFIT could happen to any of us. One constant in all of these accidents is that outside visibility was limited, or the accident occurred at night. The terrain could not be seen easily until just before impact. CFIT accidents have occurred on departures as well as on missed approaches. However, most of the recent CFIT accidents and incidents occurred during non-precision approaches and landing. Let's look at the position and vertical profile of these accidents in relationship to the landing runway. This chart shows the vertical path of these events. Notice how stable many of these vertical paths are, right into the ground. Almost all are on the runway centerline, inside of 15 miles.
Each CFIT accident has ultimately been held to be the pilot's responsibility. The pilot had the last chance to save the aircraft.
We believe that the danger of controlled flight into terrain will be reduced only through much greater awareness of contributory factors and commitment to taking necessary action to eliminate them. This involves investment in the right technology, the strict adherence to optimum operating procedures, comprehensive, effective pilot training, and acceptance of the vital need for an open, incident reporting culture.
Hello, I'm Gordon Bethune, President and Chief Executive of Continental, and also a Boeing-trained 5767 pilot. So I think I know something about controlled flight into terrain and the value of technology and safety and how all that runs to a company's bottom line. I got to tell you here at Continental that safety is an important investment, but you can't pay enough attention to putting the right investment in the right place. And controlled flight in the terrain is an issue that I think every airline needs to address. I hope yours does too.
I urge everyone, airlines, operators, pilots, and crew members, to become aware of the dangers of CFIT and to make sure that they've had the training and they have the equipment to help avoid this dangerous situation.
Let's look at some of the major factors affecting CFIT accident rates and the traps they can present. Then you'll see some of the solutions the international aviation community recommends. Accidents have many contributing factors. Investigators always reveal a chain of events that may even reach back to support organizations. 2/3 of all CFIT accidents are a direct result of altitude error or lack of vertical situational awareness.
Citation 10 Tango, turn left heading 050.
Pilots must remain aware of terrain when accepting radar vectors. Some believe that ATC will provide obstacle clearance while en route off airways. This is not true. Remember, the pilot is ultimately responsible for obstacle clearance. For example, in one accident, if the crew had known where they were and understood that the clearance they received would take them below the minimum en route altitude, the aircraft would not have struck the mountain just 10 feet below the crest. Some communication errors and misunderstandings are due to language differences, lack of standardized phraseology, readback errors, or heavy workloads. Radar vectors force pilots to rely on ATC controllers for terrain avoidance. However, the pilots must retain vertical situational awareness while under radar vectors. Barometric altimeter settings errors remain a problem. There have been cases where pilots use the wrong standard for the area.
5 octaves at 3,000. Wind 290 at 12, gusting 20. Altimeter 998.
For example, if pilots set inches of mercury instead of hectopascals, it can eventually result in large errors in the altitude indicated on altimeters. Cases of navigational errors involve disorientation with respect to the nav aid, improper transition on approach, selecting the wrong nav aid, or just plain lack of horizontal situational awareness. Today's modern airplanes have sophisticated flight directors, autopilot, autothrottles, and flight management systems. These devices make significant contributions to the overall safety of flight. But remember, these are only machines that follow instructions. They're smart, but they don't think. They do whatever is asked of them, even if it's wrong. When commanded, they will unerringly follow your instructions straight into the ground. Each crew member must ensure that both vertical and horizontal modes are correct and engaged. Treat autopilots like inexperienced crew members. Cross-check them constantly. Other factors include misinterpreting display range marks, procedure errors, database errors, or barometric pressure anomalies. In the accident you're about to see, many of the factors we just described occurred. As you watch this recreation, see if you can identify these factors.
All right, just get the KL, then make your turn to 330, and I'll give you the... How the hell do you expect to find? Hit KL beacon, return to 299, and I'll give you the...
Legacy 60, Saint 2, 400, field for the NDB approach runway 33.
NDB? Son of a bitch. Okay, 400. You've got them all set up right now. 255 and 355, and 29 after. 329 inbound. Okay. I think they're not set up like that. Yeah, you got them set up. No, they're not. 255, 355. Now, you got 255. 338. All right. I got 255, and you need 355. 255, okay. I'll give you a 355 over here. All right, you've got it. You buy there, 329. Okay, screw this stuff. Let's go over and do an ILS. We can do, I haven't even got the damn plate on it. Just keep on going down to 400 feet. 255, still going to tail beacon. It's on you. You go down, you feel uncomfortable. You don't break out, and you'll make a miss. Okay. Okay.
check, nav and auto flight panel.
Go all the way on the check.
Speed brake. Set. You want any kind of brake?
Yeah, let's put the brakes on.
Put them on there. Okay. We're given 8,000 meters of visibility at this time. Well.
Whoa, up.
So you got.
Whoa, up.
So you got the ILS there, right?
Yeah.
I'm going to put you on 14.7, and that'll give you.
Whoa, up. Whoa, up. Whoa, up. Whoa, up. Whoa, up.
Oh, I've got 100 feet on the shit.
Whoa.
This crew failed to react to 8 GPWS warnings. Why did the crew get into this situation? One of the solutions to the CFIT problem is proper training. Let's look at a training situation in the simulator where crews learn to avoid CFIT as well as perform the escape maneuver.
Before takeoff, the crew completed a departure review and briefing. Here we see them as they're going through the approach briefing. The common thread running through CFIT accidents is situational awareness. This includes not only horizontal awareness, knowing where you are over the ground, but vertical awareness as well.
We have a crossing restriction at 10,000 feet and 250 knots right here at Bondwell.
Approach charts should be studied before leaving cruise altitude. Key fixes and airport elevation must be noted and associated with terrain and obstacles along the approach path. Pilots should have a good understanding of both approach and departure design criteria in order to fully understand the obstacle clearance margins built into them. Some captains have spent hours studying a first-time approach into a terrain-critical airport. Terrain and obstructions should be studied using a chart that shows elevation contours, preferably a chart with color. Know your altitude and distance from the landing airport. Cross-check the altitudes with the approach charts or en route maps.
1,000 above.
Cross-check.
Understand that you are responsible for knowing this information, not the air traffic controller. Most modern airplanes use electronic displays that show your position. This information is a great help, but remember, errors can occur. Make sure that the navigational radios are properly set. Several CFIT accidents have occurred because the pilot was flying an instrument approach while the navigational radios were incorrectly tuned. If your airplane has a flight management computer, make sure it is correctly programmed. Each pilot should independently verify the information entered into the computer. During the approach, on most airplanes, the pilots must carefully monitor raw data from the VOR, DME, or NDB, as well as information from the barometric and radio altimeter. Use every available aid to assist you in knowing your position and the recommended altitude at that position. Hazards exist using low descent quadrant or step-down approaches. When authorized, a continuous descent angle of approximately 3 degrees is an effective way to fly a stabilized non-precision approach. Studies show that one of the common factors in CFIT accidents is the lack of a stabilized approach. Operators considered the safest in the business all have procedures about when an approach must be stabilized and what the crew should do if it is not. These same operators also have well-defined standard operating procedures.
500 above?
Check.
Communication is the key. Each pilot must have situational awareness to ensure the final descent path is correct. If any flight deck member is unsure, execute a missed approach.
Minimums?
One of the solutions to the CFIT problem is classroom instruction and simulator training for the crews. Training needs to include not only CFIT causes and traps, but recovery as well.
Based upon extensive simulator studies, we've found that unless daylight visual verification is made that no hazard exists, the proper CFIT escape maneuver is: react immediately to a GPWS warning without hesitation. Positively apply max thrust and rotate to the appropriate pitch attitude for your airplane. Pull up with wings level to ensure maximum airplane performance. Always respect stick shaker.
Pull up. Max power.
870, rapidly decreasing. 560, decreasing.
The near future will see the installation of enhanced GPWS. This technology uses a database that includes the terrain around all major airports.
Terrain ahead. Pull up. Terrain ahead. Pull up.
Incorporating this terrain modeling with the current state-of-the-art GPWS will enable the pilot to receive both oral and visual warnings much sooner than with current equipment. Let's review the major points of this program. We need to reduce CFIT accidents. All of us can help. Worldwide regulations governing flight should be standardized. This will allow aircrews to be familiar with procedures and approach charts no matter where they are in the world. Operators throughout the world must make sure that their standard operating procedures are correct, up to date, and understood by those that use them. Air traffic control systems must continue to be upgraded to include minimum safe altitude warning systems. Air traffic controllers and air crews must ensure that clearances are understood. Air crews must be constantly aware of the factors that can lead to a CFIT accident. Lack of both vertical and horizontal situational awareness. Communication errors between ATC and the crew. Ultimately, the pilot is responsible for terrain avoidance. Be aware of barometric altimeter setting errors. Always cross-check your position and know the navigational radio setup. Many accidents occur because the wrong nav aid is set in the radio. Even with the state-of-the-art electronics and autopilots, remember, they are only machines. Cross-check them. Training is the best way to make the crews aware of the CFIT problem and to give them the knowledge to recognize a problem and get out of the situation. Study and brief both the departure and arrival. Make sure everyone involved understands what is planned. Any deviations to the briefing should be immediately questioned. Always cross-check altitudes and positions. Know where you are and what altitude is safe. Good crew communication and call-outs are essential. Check the navigational radios. Unless daylight visual verification is made that no hazard exists, react immediately to a GPWS warning without hesitation. Positively apply maximum thrust. Rotate to the appropriate pitch attitude for your airplane. Pull up with wings level to ensure maximum airplane performance. Always respect stick shaker. New technological advances are on the horizon, and more will follow.
By now, you should be aware of the CFIT traps and some ways to avoid becoming a victim of CFIT. All of us in the aviation industry can contribute to solutions. Effective CFIT training is essential. Together, the aviation community can greatly reduce controlled flight into terrain accidents.